Hello everyone, my name is Sandeep and I'm going to be the host of today's webinar on how to accelerate your GraphQL Federation journey by quickly building subgraphs using Hasura. A quick housekeeping announcement first. We have a lot of ground to cover and we're using a new Zoom tool. So unfortunately that means that we can't do a live Q&A session, but we can accept your questions through chat and through the Q&A feature in Zoom. So if you have any queries, please do let us know through these media. Um, we're sorry about this, and to compensate, we'd love to set up a one-on-one consultation with anybody who has questions at the end of the webinar. So please be on the lookout for information regarding that in the follow-up email to this webinar. With that, let's get down to the agenda of today's webinar. First up, we have an exciting panel discussion with experts from the GraphQL ecosystem. We're going to get to that in a second. We're going to follow that with a feature reveal, a demo of Hasura's support for Apollo Federation v2. We used to have support for Apollo Federation version 1. We've upgraded that to support natively support Federation version v2 out of the box, and it makes it super convenient for Hasura users to build subgraphs quickly and also federate them into your federated GraphQL layer. So we'll take a look at the demo of that. That demo is so fresh off the press that the feature itself has not been merged into main, so to say, yet. So we are a couple of days away from reviewing that PR and having it included as part of the product. So please watch out for communication regarding that as well. But please be rest assured that the instructions to try this out will be emailed to all the webinar attendees, and we'll of course document that too. So that's the demo. The third part of today's agenda is going to be around our work with GraphQL Foundation. Now, when I say our, I mean the folks on the panel, folks from Apollo GraphQL and the Guild, and Hasura, and a whole bunch of other folks in the GraphQL ecosystem who collaborate under the GraphQL Foundation, focusing on trying to get as many open standards and value across to the users and practitioners in the communities. A lot of interesting work that goes on there. We'll talk about that again towards the end of the webinar. So first, let's talk about our panel discussion. We have an expert panel today, folks who are pioneers in the space of GraphQL, folks from Apollo, Jeff and Shane, who practically defined GraphQL Federation for the rest of us and built tooling around that. That's been kind of a North Star in the ecosystem. We have Uri from the Guild joining them. Uri has also been a very active participant and thought leader in the GraphQL ecosystem since the very early days and has extensive experience working with companies of all sizes, helping shepherd them through their GraphQL adoption journeys and GraphQL Federation implementation journeys as well. And the Guild does build some interesting tooling for Federation too. So I can't think of a better set of people to talk about the challenges and the opportunities that are associated with GraphQL Federation, and it should be a very interesting session for all of us. Thankfully for me, I was able to record a longer and deeper conversation with these panelists. Unfortunately, what we have today is a curated version of that. Don't worry about it. We're hitting all of the high notes and all of the interesting insights, and there are a few of them have all been captured in this curated version. We'll find a way to get the entire video out in one of our YouTube channels shortly. So we'll take care of that too. So without further ado, let's get right down to it. We'll start off with introductions, and then the panel will sort of venture into some topics that will be annotated in the curated video as well. So let's get started with the panel discussion.
So I'm Uli. I'm one of the founders of the Guild. We're an open source group that develops a lot of developer toolings, mostly around GraphQL, but also general API toolings.
Jeff Oriyama. I'm located in Connecticut, and I work as a senior engineering manager here at Apollo, and I support the Apollo client teams as well as our community-facing activities, like I represent Apollo and the GraphQL Foundation, and then some of our community-facing specification efforts as well, and really excited to be here.
Hello, everyone. My name is Shane Myrick. I'm a principal solutions architect at Apollo. I'm based in Seattle, and my day to day is working with our customers, helping them adopt GraphQL and Apollo in their enterprises.
When you're just starting out too, like, you have to assess where you're at, right? Like, I don't know if we're going to go all the way back to like learning the basics of GraphQL and what it is and how to, make something happen using GraphQL. But beyond that, like, understanding the why behind GraphQL is super important. Like, what does this unlock for you? What patterns does it enable for you? Because you have to make this mindset shift, right? It's not enough to just, I think Shane, really did a great job of explaining it earlier. Of like, it's not just about, hey, here I have this data, I'm going to expose it, do with it what you will. It is really about having a thoughtful vision for how you want your app and your services to evolve over time. And GraphQL is uniquely positioned to be that common language all the way through your business systems, through this kind of super graph layer, and to your clients, and they all kind of speak the same kind of language to define data access and data exposure. And I think that's really powerful. So really wrapping your head around that and embracing that change is going to be well worth the effort that folks put into it.
Microservices usually have stemmed from, I have some data and I need to expose it, and I don't really care how difficult it is to consume. And front ends have sort of taken that logic and that concern now for the past decade of the tech industry. And this is where GraphQL is kind of pushing back and say, let's move some of that logic out of the clients and move that back to the backend so we can have a centralized place to control that and sort of have a more shared concern and less logic spread across all these different applications. We typically see that enterprises have really started to kind of explode into the complications and use cases and technology they're using to build with today. We very commonly see enterprises working in silos as sort of microservices have grown to more even a nano service scale and level of details. Client apps have been getting bigger and more robust, but they also become now large applications in themselves that contain lots of logic. And sort of as we've grown to adopt these large applications, lots of microservices, all those APIs that service those often reflect those organizational silos that you might be working with across teams or your company, and they kind of reflect those different patterns that you see, and you can definitely feel that pain if you're trying to build something at an enterprise company today. And what we've seen with the federation and what we logically call a supergraph too is the artifact of federation. When you're attempting to build a supergraph, it sort of pushes back against those and encourages you to have more shared concerns about how data is accessed or how it's consumed or where it's exposed. And regardless of whether you're doing that with REST or GraphQL or any technology, you're forcing this new conversation in your enterprise, which is often a difficult conversation, requires us to change how we work regardless of the tech. Using federation, though, does specifically allow us to sort of line up on those patterns that we agree upon. So we can use some of the type system of GraphQL, which is very powerful, to make sure we all agree on like these things that we call these shared concerns we have across these microservices and front ends. You of course can have like the queries and operations to allow the clients that flexibility to express what they want, but still again, and sort of have that safety and that contract built in, which you often don't get with a more open REST model. And then of course the tooling that powers all that, whether that's any of the GraphQL tooling, all usually builds around this idea that everything is an artifact and that can be checked and validated and built in sort of the existing workflow we have around CI/CD and DevOps, and so everything can be hopefully a lot more strict and safe.
This whole exercise of like taking a lot of different services and exposing them through this like merged graph, let's call it. I think it's a very interesting exercise because it makes you it makes you look at the organization differently. Like you have in the schema registry, you have basically maybe all your data sources in one place and in a single language. So that's very interesting. Now you have a catalog of all the data that your organization produces. First of all, the federated architecture means that you have some kind of a gateway that then calls multiple subgraphs. There's many ways to support it, but I think the architecture that most of the community has landed on is to have a supergraph, have the subgraphs, and then have a schema registry that basically handles the organization and the changes and orchestration of all those different pieces together. For example, if you have a subgraph, and now the subgraph is releasing a new version, so you want to make sure that first of all, the subgraph schema is not, I don't know, overriding another subgraph schema or another field. You want to make sure that you're not making breaking changes, not only on the subgraph level, but also the supergraph level. So for all of those things, I think the most common architecture today is to have all kinds of subgraphs. As they change, let's say you make a change, then in the CI, you trigger a change that calls the schema registry. The schema registry takes the new version of that specific subgraph, tries to merge that together with the other subgraphs to create a supergraph schema. If it's successful and everything is okay, it goes back to the subgraph CI and say it's okay, like your change is okay. And then it also serves, the schema registry also serves the supergraph to the gateway. So that the gateway has the new version of the schema, it gets that new version, and then you can deploy that new version, and then it will know all the new changes that happened. And it can then, smartly using the supergraph, it can like smartly orchestrate the calls to the right subgraphs, while still for the consumers, it will expose in introspection, for example, the latest supergraph schema. So the schema that is up to date with all the latest subgraphs. What Apollo Federation brought to the table that I think was very, very important was tools that could statically make sure that you're doing the right things. So, so that means that you have some, let's say in Apollo Federation case, you have directives that specify how a certain subgraph is connected to another subgraph and all of those things. The good thing about those is that you can statically analyze all those different schemas and know in advance that they're merging okay, and you can build the supergraph. But for that, you need a certain outside, if you think about the development workflow, you need something that can take all that data, and outside of the development cycle of each of the subgraphs, you don't want them to release together or something like that. You want them to release as much as they want, as often as they want individually, just to make sure that they're not, screwing with each other. So that's where the schema registry comes in. So, let's say you have a subgraph and you made a change. I think the best workflow would be in the CI, in the PR of the change, you add your schema registry. There's many. In our case, of course, there's Hive. And that sends the new schema to the schema registry, the new version of the schema. The schema registry validates, first of all, if it can merge everything together and it's mergeable with the other schemas in a static way, which is very important. The second thing that it can also make sure is that it can compare also the change with live traffic. So it can actually look at live traffic that goes through your gateway and say, hey, if there's a breaking change, for example, maybe nobody's using that field. So it's a breaking change, but it's okay. Once it's confirmed, it will store that new version of the subgraph in the schema registry and notify the subgraph. It's fine, you can merge it. You merge, the subgraph can release a new version, and now there's a new supergraph schema sitting in the schema registry. Now the gateway can take that new version of the supergraph and release and update themselves. Like there's many methods of doing it, and it depends on the workflows.
So an interesting point that we often hear is sometimes GraphQL is challenging to learn for new users, and sometimes takes too much time to maybe set up if you're new to GraphQL. And oftentimes we hear that from users who have not actually deployed anything to production. They try going through this learning process and ends up not panning out, and they go back to sort of building their REST models, and this we just have this data, we just want to expose it, and so we expose this very small custom REST API to quickly get up and running. But when we reflect on some of that points before, right, it's not necessarily the technology that was making the change here. It's more the concerns and the shared responsibility that we're now delving into that we start solving with the supergraph. When you're choosing to build these supergraphs, you're diving into this opportunity to centralize a lot of that business logic, or that's business rules you have spread across your front end, your shared microservices, your database wrappers. We're taking that opportunity to spend a little more time designing it and thinking about that work up front and moving it into this shared space.
It's a very good question and a very broad question. I think the hardest thing, I think, is always to adapt a new technology. Like most companies, like serious companies, they already have a technology in place. So I think that means that you should, the hardest thing, like you want your toolings or the toolings that you want to use to be as flexible as possible and to integrate to existing things as easy as possible. I mean, a good example is Hasura, right? Like you can take any database and just use Hasura, and you have like very easily you can set up a subgraph. That's much easier than like telling the team you need to build something in order to support this new spec. So I think this is a great example. We use the same approach with Mesh. Like we say, even if you have REST APIs or gRPC, it's okay. I think Hasura also supports like bringing REST APIs. So those abilities to use like your existing APIs and to bring them into the federated gateway, into the federated architecture, I think is very important. It's not always necessary. Like you can still write manual subgraphs, and you can still manually, pick the fields and build new servers. I mean, that's good. But I think there's so many teams that are, we want to use their data, but they don't want to learn. They don't want to learn federation, or they don't want to learn a new spec, and maybe they don't even want to learn GraphQL. So this ability to use their existing data sources and the existing technology that they use, and then just expose that into the API ecosystem of the company, I think is a great win. Then I have all kind of automatic tools that actually both saves me time, but also saves me from asking the original team, the data source team, the services team, to make any changes. I can adjust the APIs to how I want to expose it, and they can work how they want to work. So I think that makes adoption much, much easier. And if I would say in certain companies, it's a must, right? Like if you would ask them to build like a new GraphQL server, or to change technology, or to learn a new thing, like there's some teams that just would never happen. They would never do it. So I think it will be very important to have the tools to basically build subgraphs in a structured way and in a fast way, because it's very soon, I think we'll get to the point where if your tool is not connected to that graph, nobody's going to query it. And there you want something, if you're now going to manually, write everything, that's okay. But like, I think it's very important to have very strong, powerful tools that will make you build, that will help you build the best subgraph into, that will actually contribute in the best way into your supergraph that is not polluted, it's very performant and efficient, and hopefully also with as minimal manual code as possible. So you want to add a certain source into it. The work is minimal. You don't need to now have a lot of burden maintaining it on the long run, because most of the code or most of the infrastructure is doing it automatically for you. The infrastructure is very performant, so you don't need to care right now into optimizing things. You just need to connect into the supergraph. I think these are very, very important, and I think Hasura is a perfect example. It's like you take a data source, and Hasura does so many things automatically for you and is extremely performant. So and does most of those optimizations like out of the box. So I think this is a good example, and I think tools like Hasura, I think, would actually help the ecosystem, because it will help push a lot of sources that are today not part of the supergraph into the supergraph much quicker than if we would have to now build custom servers all around the world. Like most of the data is there waiting for us to take. It's not something we need to build. So I'm really excited about actually all of us working together and collaborating, because I think there's such a big opportunity right now, and having automatic tools like Hasura, just super quickly adding tons of tools into the ecosystem and exposing them into the supergraph, I think is fascinating and great.
In today's webinar, this is the problem that we want to solve as part of this demonstration. Let's say you're an engineering team and you use Apollo Router or Graph OS to federate over your GraphQL subgraphs, and you have a few domain databases or sources that you want to quickly bring into your federated API layer. And the problem before you is that you want to do this quickly and be able to leverage the fact that you have multiple subgraphs and joins across these subgraphs as quickly as possible. So that's the challenge in front of us. And to be able to do this, we need to be able to generate GraphQL subgraphs that are first and foremost high quality APIs. The GraphQL APIs need to be high quality. They need to support the demands of your client applications going forward. So they need to be expressive, and you can't just generate a low quality API on top of your domain databases. So that's a key requirement of this problem. The other challenge ahead of us is that whatever GraphQL subgraph we generate over our domain need to be performant. So that's the challenge ahead of us. That's the problem statement. And today with Vamshi, who's a principal architect at Hasura, we are going to solve this problem by using Hasura to generate these subgraphs, which will aid the process of bringing domains in your enterprise into your federated API layer as quickly as possible, with as rich an API as possible, and a performant API on top of that too. So please join me in welcoming Vamshi. Vamshi, thank you so much for doing this demo for us. I'm going to stop sharing my screen and I will turn it over to you to help us go over this demo. So over to you.
Hey folks, I'm going to get started with the demo. I have two different databases here. I have a users database, which has an author table that has some sample data. And then I have a content database, which has an article table with some sample data. Now what I'm going to do is I'm going to expose these two databases on two different GraphQL as two different GraphQL APIs.
So two subgraphs, which we will eventually federate using Apollo router.
So
all right, if this part of the demo makes it to the final video, then for the folks watching this, Vamshi is trying to get the next generation of Hasura that's written in Rust up and running. So you see some Rust commands, cargo run commands, all trying to get Hasura v3 engine up and running for each of the subgraphs.
right. Okay, so I have two GraphQL services running, both powered by Hasura.
All right.
So what you are seeing is the configuration that powers these GraphQL APIs. So the service on the left just exposes the author table. You see some like a Hasura metadata for it. And on the right, you see the service that exposes the article table. Let me just quickly. So this is the author subgraph. I'm gonna query this thing.
All right. So this is that was the author subgraph. I'm guessing now you're going for the article subgraph.
Yes.
That's conveniently available at 6002. We have articles, article ID, which needs to have an author ID field.
All right. So now what I'm gonna do is I'm gonna define some Apollo Federation specific directives on top of these APIs so that.
Vamshi, before you do that, just to confirm for our users, so what we're looking at on our screen right now is the configuration of Hasura that allows us to work with the databases that you showed us to instantly generate a GraphQL endpoint with a quality API. Would you mind maybe just going back to the API ones? Can we just see any of the subgraph APIs just to take a moment to recognize that with some configuration? I think there's a little bit of that in VS Code. We've done a lot of innovative things to help author that metadata in as flexible a way as possible and as fast a way as possible as developers prefer to do. Yeah, can we check out the subgraph in some more detail? Can I see some of the I see some filter clauses. I see a where clause here. Can we maybe check that out? All right, I see some Boolean operators. I have some equals. So all of this is something that I get just by virtue of adding some metadata in Hasura and connecting it to my underlying domain database. All right, so I have clearly some order by magic happening here. We were just looking at the where clause, lots of filter options available, and I see limit and offset, so I'm guessing paginations available as well. So the terms that I see here are very, not so surprisingly, similar to the SQL that Postgres supports, or most relational databases support. So is Hasura is kind of leveraging the underlying database and providing you with the semantics to query that data in your GraphQL API layer. So the quality of the API seems on par with the SQL of the underlying source. So that's amazing. That doesn't get more expressive than that. So that is interesting to see. All right, Bumpy, so go on. So we have our subgraphs ready now. A bunch of metadata added to Hasura, talks to the database, and 2 subgraphs, one each for article and author, is available. All right. So what are we doing next? Is the next stage of the problem to make these federation compatible so that we can make them work with the Apollo router?
Yes, make them federation compatible and also like query across these 2 services. For example, I would want to fetch the author details. I only have the author ID here in my article subgraph. I would want to fetch the author details too, something along these lines. Author first name. Like this doesn't work because the subgraph has no understanding of the author data.
Understood. So we're extending that and we'll be defining relationships between the two. So eventually what we want to do is fields from subgraph 1 plus fields from subgraph 2 all sent to Apollo router, and router will take care of things for us if we set things up, which is exactly what you're going to show us now. So, all right, over to you.
Yes. Similarly, on the author subgraph, I would also like to fetch the articles associated with that particular author. So let's see how we do this.
Yes. So we're going to do both a one-to-one as well as a one-to-many relationship using federation. All right, that's awesome.
Yeah. So I have the same author type, except now I am defining Apollo federation keys on top of it, identifying author ID as something that uniquely identifies a value of author type. And then I'm gonna go head to the author model, like the one that actually powers the API, and specify that this is a source for that particular entity that we have created by declaring the keys directive. And similarly, on the right-hand side, I do the same thing for article. I define the federation keys.
Understood. So this will add the add key directive on each of the subgraphs, I guess. Okay.
Then what I want to show is that now we define a stub type called author, where we only define the author ID, the one that uniquely identifies an author, and define keys directive for it. The interesting thing about the author subtype, author type here is that there is no model backing it. And we would extend this, we would then go and extend the article type by defining a relationship. So I am going to first look at this particular relationship definition where I am extending article with a new field called author. And I define like how that needs to be resolved. And similarly, now I go to author and define a relationship called articles. And the kind is array. So what this enables is that, so I'm gonna restart with this new configuration.
So this is all part of the Hasura metadata, which lets the subgraph know that it's being prepared to work with Apollo Federation. So it needs some of those directives that a graph OS or router needs to make sense of subgraphs. So that is essentially what we've done now.
All right. So nothing really changes on the author subgraph there because of the keys directive we've added on author. You have the entities field that's generated.
Yeah, this one's new. Yeah.
And then we'll go to the article subgraph. The interesting thing about the article subgraph is that you now have this author, like the stub type, where you could like resolve the author ID, and that's it. So now we start the router, but there's another.
Just to pause here, Vamshi, what you've shown with this author field, which is new, which wasn't there before, is that the stub works, right? Because the article table obviously already has author ID. So we've now made the subgraph register the stub and kind of show the author ID, right? Because that's exactly what we're seeing here. Okay, got it. Okay.
And similarly, we've added the articles field to the author type. So we can see that like this articles, this is the relationship that we have added.
All right.
So now let's see, let's start Apollo router on top of these two subgraphs and query across these subgraphs. So I'm gonna use Rover to generate the supergraph schema out of these subgraphs. Let me just show the configuration here. So this is the configuration that is being used. So I have two subgraphs and generating a supergraph schema on top of these two subgraphs.
Got it.
So now I use router on top of this generated supergraph schema. The router is running at 4,000.
Nice.
So let's look at the interesting things here. So one is that what happens to the author type. Because of these annotations, you could see that it has fields from both the subgraphs. So subgraph one, the author subgraph has only defined author ID, first name and last name, while the article subgraph defined author to have both the author ID and articles. So now you have like a unified type here. If we go back, let's see. So just gonna many fetch.
You're getting a list of articles and you're also getting the author's first name and last name, which is obviously not possible unless you're able to join these two using router.
If we go back to the article subgraph, you could see that we can only fetch author ID. There is no first name and last name.
Right.
If we go to the unified service, you can see that we could fetch both first name and last name. Similarly, I could do author, fetch first name, last name, articles.
Okay, you're getting the title. Okay, got it.
But if we go back to the author subgraph, we know that there are no articles here.
There are no articles here. So you've established that one-to-many relationship in the second part of this query. And so for each author, John Hughes, there are two articles. Okay. So that's nice. So in the same query, you have an example for a one-to-one relationship between articles to each article's author, as well as a one-to-many relationship from author to their articles.
Yeah.
All right. This is amazing.
There's two organizations. There's the specification and the foundation, and the latter supports the former, which is exciting. And so on the specification side, specifically about this, we've been really involved in the GraphQL working group and many sub working groups and there are many of those at this point, which is really exciting. Federation, or at least the ideas and substance behind federation, have become sort of the industry consensus over time. What we started 5 years ago is really spread throughout the community, and there are now like multiple tools that support composition and distributed execution of GraphQL servers. And when you have that sort of parallel development happening on multiple tools, solving a similar problem space, we run the risk of fragmenting the ecosystem, right? And we don't want that, the community doesn't want that, and our users don't want that. So we're all doing something about it. The composite schemas working group is part of the GraphQL specification. It's now meeting regularly. And we and many others, along with folks like Chili Cream, the Guild, some engineers from Hasura have attended some meetings, AWS, and many other contributors. We're all kind of working together to create a description of how composition and distributed execution could work, right? And we're still in the early stages, but we're really excited at the progress that we made as a group so far toward that specification. And if anyone in the audience is so motivated, please do come to a Composite Schemas working group meeting, any GraphQL working group meeting. The calendar's public, and you'd be surprised how easy it is to get involved. And ultimately, it comes back to what I was saying earlier about empowering others, right? Enterprise GraphQL adoption is on the rise, and we have to be excellent stewards of that technology, both as as independent developers, as vendors, as a community.
What we started doing was looking into the similar stuff that are happening everywhere, and we realized like we means a lot of people, by the way. It's us, the Guild, Hasura, Chili Cream, Apollo, Wondergraph, like many vendors. I'm probably forgetting more, but like AWS, IBM. There's many companies that went into this direction and said we should specify also this. We should have a spec also for that type of architecture, and that's very exciting because we get to sit together, all the different vendors of that ecosystem, basically almost every week. There's like a monthly meeting, but then there's also like small subgroups that's happening almost every week to specify that and to look into specifying the composition, specifying the directives, specifying the supergraph. Maybe like we're looking, we're gradually specifying more and more. We also don't want to specify too much, like because we want to keep the ecosystem evolving and keep the innovation coming. So but there's a lot of but it's very exciting because like here, first of all, we learned a lot from each other in those meetings, and those meetings are open. Anyone can join, so I highly encourage people who are excited about it to also join those meetings. And we end up with like an open spec under the GraphQL Foundation.
Okay, great.
Thank you so much, folks. Again, really appreciate you taking the time out for this.
It's great meeting you.
Nice meeting you as well.
Thanks, Sandeep.
Bye.
Good seeing you as always, Shane. Later.
Thank you all for making it to the webinar. I'll quickly switch over to the reminder slides. Officers will help you with questions exactly like this. We can get into more details. You can share a screen and look at documentation and even your code and configuration. So please do join us there. And if you're a Hasura user, would love to see you at HasuraCon. And with that, if there are no other questions, I will take your leave. Thank you again and see you at our next webinar. Have a nice day, folks.